Okay, so let's get started, guys. So thank you everyone for joining who are here. And it gives me immense pleasure to be here and conduct this live session on software testing fundamentals. So it has been getting postponed for quite a while, but then I thought finally we need to get started. So this is kind of the first session, and there'll be multiple sessions or more sessions coming through. So you'll be getting invites. Now you are one of the first 300 registrants. So the spots went very quickly. So I had to launch another portal basically to other candidates who will get these recordings later. But then you are one of the kind of early bird people who have registered, enrolled very quickly. So yeah, let's basically get started. So what I'll do is I'll share my screen, and then please let me know once you see the screen. Okay, please raise hand if you can see my screen. Great. Okay, great. You can lower your hands. So all right. So basically the key purpose today is to understand the fundamentals of software testing. And why do we need to understand the fundamentals? Because I believe in the current market of testing and software development, testing is kind of uh, being forgotten, and people in testing field as well are talking about data structure, algorithms, complexities, and not talking about fundamentals, right? So fundamentals are the most important aspect of software testing, because the core purpose of testing is to improve the quality of the product and to deliver quality product. It's not about writing complex programs and complex frameworks, which then you end up being maintaining themselves, right? Or maintaining those complex frameworks or automation, UI automation framework. I don't say that you don't need to learn automation, but fundamentals need to be clear first. And that's where this training is here, so that we understand fundamentals first, and then we start building the automation capabilities. If you have been following my channel, you will see that there are so many automation courses, but fundamental course is kind of lacking there. There is one fundamental course on software testing and ISTQB, but then this is kind of a course that will be a go-to course for you guys to go ahead and start building your career if you want to go ahead into the software testing. So mostly this course is for the freshers, college students, or people who are like 2 to 3 years experience in the software testing field. Still, there'll be a lot more fundamentals and things that I'll be discussing in this course. Okay, so quickly, let's see what is testing. Right now, before we get into the details of what is testing, first we need to understand basically where does testing happen, right? So testing, you can't skip in any of the product that you use day to day or the services, right? Basically, so if we are talking about the product, say for example, electronics product, you buy anything in the market, do you think that it is being delivered to you without doing any sort of testing? If you go for a blood test, right, so they take the sample, the blood sample, and then they perform some tests on that sample, and then verify or basically check that if the cell count or other criteria within your blood are within the range, and provide you the report accordingly. Similarly, automotive, right? So cars, anything that you see, that you use day to day, is basically tested or follows a testing life cycle before it comes to the market, to ensure that the product is of good quality. When we say quality, is basically if you are using something, right? So say for example, you bought a mixer juicer, okay, and you got it at your home, and you just plugged it in, and it just boom, it didn't work, right? There is a smoke coming from the juicer. So what would be your instant reaction about that particular company that for which you have bought that product from. Now, the reaction would be like, I personally, I wouldn't go for any other product from that particular company. I'll choose for alternative, right? So this is basically why any product that comes into the market needs to be tested to have quality, to deliver the quality product so that customers are getting what they need, right? Now, if we talk about the definition, so testing is a practice and process of making objective judgments, right? So when we test, we are able to make objective judgments regarding the extent to which system either meets, exceeds, or fails the stated objectives. For example, if you are testing any electronic device, right? So you apply the voltage and a current to a circuit and see if the measured value is within the expected range. You will say, yes, it is basically good in terms of to be moved to the next phase, right? So it gives you, testing gives you the criteria or basically the ability to have some objective judgments. Okay. Similarly, for blood tests, it will give you an idea. So there is a range for the blood test. If your test or cells are within that range, it's all good. If it is out of that range, so basically it gives that that judgment to the person who is doing blood test that yes, these type of cells are out of the range. So basically this is what the report will look like. So so overall, there is a practice, there is a process. So when I say process, basically there'll be a person who will be collecting the blood, right? Then the sample is going to a particular place, it's being tagged properly, then tested. So it's a whole process that happens, and then overall testing happens. So it's applicable. Testing is everywhere. Any product that you use, it is being tested, follows the process, and then comes to the market for the consumers. Okay. And why do we need to test? Basically, the companies don't want the surprises from the customer. Customer needs a quality product, and that's where testing becomes really, really important. So this is in general testing, right? We haven't come to the software testing yet. So this is in general testing. It can be applicable to any of the fields. So these are the three examples that I took, but go ahead and explore some of the more examples. Now, what is software testing? Okay, so as we know, testing is basically testing of any of the product that is released in the market. When we test software, right? Any application, it's in the phone, you access through the computer, it's installed on your desktop, it's a software, right? So when you test the software, it's software testing. Okay. Now, software testing is again similar. It's not a standalone activity. It's the process of evaluating. First thing, you evaluate, and then you verify that the software product or application does what it is supposed to do. Okay. So that's very important, that we understand that testing is not a standalone activity. It's basically a whole process to evaluate and verify that actually the software, as we have discussed about the other products like electronics products or car and etc. Similarly, software should also meet the end user needs, right? So that's where software testing lies. Okay. So let me so somebody raised the hand. Okay, give me a moment, guys. What I'll do is let me stop sharing, and okay. So I'll make someone, so to basically allow to talk. Okay, sorry. I think so. Praveen, are you okay? Are you happy? I have allowed you to talk. Basically, in case you're not able to see something, you're not able to hear, you can talk. Or if you're not comfortable, can someone raise their hand who is comfortable in talking and letting me know if something goes wrong, that you're not able to see? Or Okay, who is who has raised the hand? Sorry, let me see. Okay, Nitin, I'll allow you to talk as well. Okay, so Praveen, I'll disable you. So let me.
Everything is fine, sir.
Okay, great,
Yes,
great.
sir, everything is fine.
Okay, great, great, great. Thank you, Nitin. Let me. All right. Okay, let me share again. Sorry about that, but I think it's important. Sometimes I keep talking and okay. So now what are some of the benefits, right? So what are some of the benefits of software testing? So basically preventing bugs, reducing software development costs, and improving performance. Now, when we say preventing bugs, that's very core and basic thing that you will do when you're testing the software, right? So you, as the tester, will be involved in the life cycle, basically across the software development life cycle, and you will be kind of a team or the testing person that will be helping people to basically, or the team, the development team, to prevent the bugs, right? So providing your inputs, if there are any gaps within the requirement, there will be inputs required from testing all across the life cycle, so which will help eventually in preventing the bugs. Then reducing software development costs, which I'll cover later, that testing helps in reducing the development costs, and then also last minute surprises wherein the companies have to shed millions and millions of dollars to fix those defects that go into production, right? So it depends, like if there is a mission critical software that has some defects, the whole project itself can go wrong, right? And the whole product itself is kind of a waste. So the amount invested will be a waste if testing is not done properly and it's not kind of compliant, things like that, right? And then eventually, like, improving performance is another kind of a important benefit. Now, if we move next, we need to understand that software testing is a process and software testing has objectives. Okay, when we say software testing is a process, that means software testing, you don't need to think that it's a standalone activity, you are just involved in one particular phase. It used to happen when we had this waterfall model, which had a lot of drawbacks and shortcomings, and that's where agile came in picture. So it has evolved overall, like V model and iterative development model, and finally agile and scrum. But then previously it was more of the testing was a siloed approach, it was phased, it was into a particular phase, right? So that was the case, which was long ago. Now things have changed, and it's a continuous kind of complete process wherein testers are involved in each and every phase of the software development lifecycle. So it's a process. It involves static and dynamic testing. When we say static testing is the testing technique wherein you go through the documents without executing the code. Say, for example, you have the requirements document. It will be a Word document wherein somebody would have written the requirements. It will be either in Jira, they would have written a user story, right? So user story is a requirement written in form of a end user, how end user is going to use the system. So it's kind of a requirement written in plain sort of English. So when you are going through those requirements, analyzing those requirements, reading those, exploring those requirements with the development team, understanding, and then coming up with the test scenarios, and also discussing the shortcomings in those requirements, that's sort of a static testing. And it's not just specific to requirement, it's basically when you analyze the design document, you see if there are any errors in that, right? So basically all of that is static testing. Why? Because you are not executing the code, right? You are not launching the application as such. When we say dynamic testing, you are actually launching the application. When we say launching the application, what it means, if there is an application on your desktop, when you double click, it opens, right? So that's basically a dynamic when you launch. So what happens, that software gets launched, the code behind that particular software runs, and you get some functionality and feature in that particular software. Say, for example, Word application on your machine. So if you have a requirement document to build a word type of software, right? So Microsoft Office type of a software, and you are just reading those documents that this is how the icons will look like, this is what the functionalities. That's static testing. But when you actually on your computer, you double click on the word icon and word icon opens, and you are actually doing some writing, formatting, coloring on the word document, that's dynamic testing. Okay. So when we say dynamic testing, it's basically launching the application. Now that's the standalone application that I have to. Now, if you talk about the e-commerce websites, for example, right? So you actually open the browser, you go to the say amazon.com, you launch the website, you add items to cart. That's the dynamic testing. Okay. And if you're just analyzing the static documents, reading through, analyzing, writing test case, that's basically the static testing. Now, software testing requires planning, preparation, evaluation, reporting, right? So you just don't go ahead and randomly start testing. Okay. There is a lot of planning that's required, and it's not necessary that you just write 30 pages, 40 pages test plan. It's not like that. It's currently things have changed. It's not that you have to go ahead and write 100 pages of documents for the planning and preparation. It's more of planning and understanding how you are going to achieve, and then documenting it in a very bare minimum sort of format that is that should be captured. Say, for example, what you're going to test, what you're not going to test, who is going to test what is the timeline when you should be testing, okay, and when you should be finishing. Okay, so overall of all of that is the planning. When you think about what is in scope, not in scope, what will be the timeline, etc. Then preparation, right? So you also prepare your test cases, right? You go through the documents, user stories, requirements, then you start preparing those test scenarios, then test cases out of it. So you evaluate, you prepare, you plan, and then you report how how the execution has happened, what sort of test cases you have planned, how many of those executed, if 100% of those got executed, how many defects got raised. So all of that reporting is also included, right? So it's kind of a whole process wherein you do a lot of activities. And then you need to test not only the software, but also the related software products. Okay, when we say related software products, so if you would have seen that any software that you buy, right, there is a readme document, there is a quick install guide, all of those documentation that you get through the software in the folder, all of that needs to be tested, right? The documentation for the software, like how you are going to use the software. Okay, if you just bundle software and say, for example, if you are not aware of the word functionalities, you can go online and search for all of the word and excel related functionalities and features on the Microsoft website, right? So don't you think that all those documentation that have been done, they are related work products of the software? Which software? The Word software, right? So Word or Microsoft Office software. So that documentation also needs to be tested, right? So it's not just the product, but any related work product around that software also needs to be tested. Okay. Now, what are some of the objectives of software testing? So some objectives are basically you prevent defect, which we saw previously as well. You determine that software meets the product requirement, right? So if I'm looking for Apple, I should get Apple, right? I should not get orange. Okay, so that's what basically meeting the product requirement is. So if I am looking for a software wherein I need, say, for example, my training portal itself, right? So I have very basic requirement that there should be registration functionality wherein people should be able to register using social media account or using their email. Then once they register, they should be able to access my courses, they should be able to buy them, they should be able to basically enroll in the course, and then also go ahead and watch them seamlessly without any issues. For me as a tutor and teacher, I should be having the capability to have the admin portal of that software. Okay, and then when I log into the admin portal, I should be able to create courses, upload videos, upload the quizzes, documents, etc. Right? So these are some of the requirements that I as a tutor have, and I think my end user, like students like you guys, need in the product. So my portal, training portal, whether it gives me all those capabilities or not, that's what, if it meets, that's basically, yes, this software meets my product requirements, and that's why the portal is basically sufficient for me. So it's kind of accepted solution, and that's why it is basically in production, in live. So software should meet the product requirement, whatever end user is looking for, or the person who is asking for that particular software. Like you people, if you want, if you say you are using Gmail, what is your requirement to use Gmail, right? You should be able to draft email, you should be able to send it successfully. It should not like you are not able to draft, you are not able to format it properly. When you send it, there are some errors, SMTP errors, it's not getting delivered. That's not going to help. It's basically, then in that case, the email software is not meeting your product requirement, right? So that's what you do as the tester. You put yourself in end user shoes and you see whether the software, whether the end user or the requirement that are being documented in terms of user stories or end user, whether those requirements are being met. Okay. Then the third thing is whether the software is fit for use, right? So even though the software might meet product requirement, but what in case the requirement themselves were documented incorrectly, right? So if requirement themselves are documented incorrectly and you have tested as per the requirement, your product is okay, right? It meets the requirement, but then is it fit for use? When we say fit for use, like if the requirement says, yes, this is the word document, or let's say email example. Okay. So the requirement said that user should be able to draft the email. Okay. And format the email with more colorful colors and everything. But the requirement didn't mention that user should also be able to send it. Okay. So the people who are collecting the requirement or basically documenting the requirement, they assume that this is the functionality everyone will understand. But then as the tester or as the development team, people build as per the defined requirement. People don't assume, developers don't assume, testers don't assume, right? So testers go a little further down the line. They think they think from the end user's perspective. Okay. So in that case, if the requirement didn't say that the emails should be sent as well, so development happened with just um, drafting the email, different color formatting and everything, and nobody tested for sending that functionality. So is this email software, if you say, just say the Gmail application, is this fit for use? Absolutely not, right? Even though it is matching exactly what the requirement said, but then what will you do with just drafting an email and keeping it in your drafts, right? If you're not able to send, there's no point of using that email agent or software wherein you can't send emails, right? So that's where testing, software testing goes a step ahead to put themselves in customer shoes and see that the software is actually like, yes, maybe there is a miss in the requirement gathering, right? That's where you, when you do static testing, you ask these sort of questions to the stakeholders, like, okay, this is the Gmail, this is the email client that we are building, but we didn't articulate it anywhere that we need to basically send the email as well. Are we missing something, right? So testing is not about just going through and whatever you have got the requirement and going through and testing and that's it, right? Testing is about also getting involved and providing the value to all the members of the team in this overall software development lifecycle. Okay. Now, the finding failures, defects, bugs is by default, right? So when you are in the execution phase, you will do it. When you are not in the execution phase, you still keep doing it. Even in the requirement phase, when you are analyzing those requirements and giving feedback, it's basically finding the defects, failures in the static documents. Then reducing the risk, obviously, when you test well, when you um, fill all the gaps that are there in the requirement in the product, the risk reduces and the confidence builds in the product. Okay. So this is where the software testing is a process first thing, and then it has objectives. Okay. Now, when we say testing as a process, right? So it's not a standalone activity. It's a series of activity. So I have explained in much detail, but then briefly, when we talk about software development lifecycle, software development lifecycle is the development life cycle of the whole product, basically. So if, say, for example, the team is following the waterfall development approach. Okay, so it was more of a earlier development approach wherein there were phases, so requirement gathering, design, then development, testing. So all of that phases were there, and very siloed sort of approach. So testing is kind of a part of this whole development life cycle, right? So it's not kind of a standalone activity, but it's basically analyzing the requirement, then analyzing the design document, coming up with the test cases, etc. There were some shortcomings. There were basically not some, many shortcomings in the waterfall approach, that it was not as in the testing team was not as involved as it is today in Scrum and Agile. But then testing was still kind of done in all phases of software development lifecycle. So testing is kind of a subset, you can say, within the development life cycle. So testing and development life cycle go hand in hand. It's not kind of a separate tracks altogether. Okay, it's kind of very gelled approach. Now, starts with static testing. Still is the case, like in even in Agile and Scrum, you will definitely do static testing. You will analyze the document, you will provide the feedback, and then overall, after the static testing, you go ahead with the dynamic testing when the build is available, wherein the developers have actually gone through the requirements. They have coded the requirements using any programming language. They could use Java, Python, whatever. So there are hundreds of programming language. They can use any of those to build the software. And when you actually launch the software and verify basically that it's fit for use, it meets requirement, that's the dynamic testing. So it's kind of the overall process. Testing is a complete process within software development lifecycle. It involves both static and dynamic. We have understood in a lot of detail. So basically, when we say static testing, it's kind of a when you go through the document. So some examples like technical reviews, when you just walk through the document, or you do the peer review, right? So I have written the test case, or somebody has written the code, somebody else is looking at that code and seeing that, yes, everything looks fine. I have written the test cases, and I'm asking my peer, my colleague, to basically go ahead and look at those test cases and see that if everything looks good. So these kind of reviews happen, the walkthrough inspection, the static code analysis. These are some of the examples of static testing. Now, when we talk about the dynamic testing, so it's kind of to validate by launching the application that the software is meeting the requirement and it's fit for use. Okay. Now, what are some of the test levels? So very important test levels during the dynamic testing, right? So because when you do dynamic testing, that's when you categorize the testing into different test levels, right? So this is something which I recently asked in one of the polls, and to my surprise, I mean, more than like almost 30% of people have given wrong answer to this question, like how many, which of the testing is not a test level. And that's where 30% of people who are kind of working in the software industry don't know this, right? So test levels are for when you do testing at the unit level, so basically by the developer. So unit testing, then integration, system, and acceptance, right? So these are the 4 levels of testing, wherein different testing types, people get confused with the levels and types, right? So but types are many, but then in terms of levels, there will be only 4. So unit testing is the testing of the smallest testable part, okay, testable code or method that the developers write, and mostly it will be done by the developers. Then integration is when these small modules are being integrated. So unit testing is something, if we take an example of the car, right? So what is the smallest unit that you can think of in the car? It could be like, if you try thinking, you could think like, okay, wheel is the smallest unit, but then if you break down the wheel as well, it has tire, it has tube, then it has a small, bearing, and then within the bearing there might be a small unit as well, which you can test, right? It's not something that you will break and test, but then the bearing that can be tested, the smallest part of the bearing that can be tested, you can think of unit as something that ball bearing. Okay, now when these small things integrate together, right, they make a complete bearing. Okay, that's what, so together when they are integrated, that's what integration testing is, right? So if you correlate that with the software, it's kind of similar. So the smallest testable part, right, not the part that you will just say, no, I'll break it down and then I'll test the molecules. No, it's not like that. Okay, so the smallest testable part of the software, it could be a method wherein you can basically write the unit test. You say, for example, there is a method add two numbers, right? So you can write test cases to pass in two numbers and see that the addition is right. Okay, so that's the smallest unit that you can test. Then when these units are integrated, so for example, there is addition function, there is a multiplication, and then all of them are being added together to form the calculator functionality, wherein you can add, multiply, subtract, divide, right? So when all the modules are integrated together, or more than one module get integrated, so if you test that integration between two modules or more than two modules, that's integration. And there are different levels of integration testing as well. Now coming to system, it's basically the complete system as a whole. Okay, so if we take the e-commerce website, okay, or say for example the word document or Microsoft Office, when the whole functionality is available, it's installed on your computer, and you are launching the application, trying to do end-to-end sort of testing, opening the blank page, documenting, formatting, saving, right? So all of that complete module or a system as a whole is system testing. And then acceptance is more of whether this particular software is fit for use when the customer does the acceptance, right? Or a team within the organization, um, apart from the development team, maybe the business or the product owner or anyone who is sort of a face of the customer, they go ahead and see that yes, it is actually acceptable software, it's fit for you. So that's the acceptance testing. So these are the levels. Okay, these are not the and then when we say types, then there are many types of testing. Okay, so memorize this, but basically that levels, there will be 4 levels. Okay, now testing requires planning. So yes, I have briefly covered that we need to plan. We need to plan what you want to achieve as part of the testing cycle, right? Then who will do what? So like, it's not single person who will do testing of the whole product until it is very small product. So if you are a team, then what needs to be achieved? And then if there are 10 people in the team testing, then who will do what sort of testing? Who will do functional testing? Within the functional testing, who will do other module testing? So there will be different modules which will be allocated to different peoples. For example, e-commerce website. So module, you can think of something like the login module, right? So login module, who is going to test? Then registration functionality, who is going to test? Then if we talk about the adding to cart, okay, checkout. So these are different modules. So who is going to test all of these modules? Then if we talk about, time frame, by when we are going to test, so all of that timeline. Then any control, some control the test progress, control activities that need to be there in case the plan is not going as per expected. What are the control measures that need to be there? So all of that needs to be planned. Then summary reports, once testing is done, preparing summary report, etc. Okay, now testing requires preparation. So basically, once test plan has been finalized, so you need to do test preparation. Okay, so once you have planned, yes, this is what we are going to test now, and this time frame, and this is what the testing team is assigned. So based on that, team will start working on the requirements that are being assigned to them and start analyzing preparing the test scenarios, test cases, what sort of test data will be required when you are going to test those scenarios, right? The test, when you are going to execute those test cases, in what test environment you are going to run, right? So test environment, when we say, so for example, if you open any website, for example, flipkart.com, right? So that's a production environment, right? It's available to all the wider audience, like anyone can access the website who wants to buy something, and they can access it. Now within Flipkart, within Amazon, every day they do the development, they add new features, right? So when they add new features, do you think directly they will just go into and push into the production environment, and that's where testers will test? No, there will be a dedicated test environment wherein the new features will be added. Okay, and then based on the new features, whatever will be added on in the test environment, they will be basically testing. The testers will be testing in the test environment, and once everything is looking good, then the that particular code will be moved to the production. Okay, and then any other sort of prerequisite. So there are a lot of things that go into the preparation, but overall, like high level, this is what the preparation is all about. Okay, so I think somebody raised hand. Can you please ping in the chat if you have any questions? I think everyone is having access to chat window, so you can ping. Yeah, Jairam. Please ping it in the chat, and I'll take up the questions. Okay, so if you have any questions, ping in the chat, and I'll take up those questions later. Okay, preparation. Now the next one is testing requires evaluation. Okay, so during test execution, you evaluate the software to make sure that it meets end user requirement, it meets the exit criteria. What is exit criteria? So basically, exit criteria is the defined criteria when team discusses and they come up with the criteria, basically that there shouldn't be any severity 1, severity 2 defect, right? So positive functionality of the product should be working perfectly fine. So these sort of pointers or bullet points are being mentioned, that yes, until and unless these criteria are met, we can't say that testing is basically complete, right? So that's the exit criteria. And when we talk about the agile, it is basically definition of done, right? So you can correlate exit criteria with definition of done in agile, and entry criteria with definition of ready in agile. Okay, and then evaluating functional and non-functional aspects of the software. So functional aspect is like actual functionality of the software, wherein user launches, user adds item to the cart, goes to checkout and checks out. Non-functional aspect, how quickly checkout happened, right? Or how when I launched the website, how quickly the website got loaded. Am I just waiting for 10 seconds to load the web page, right? That's kind of a slow website. So non-functional aspect is how quick the transactions can happen, right? So this is just a one sort of aspect of non-functional aspect. Okay, now software products and related work products. So basically you also test the software products and related work product. It's not just the software, but anything related: design document, reference guide, training material, user guide, installation guide, right? So all of that needs to be tested, and any other related work product needs to be tested as part of the software testing. Okay, so let's take some questions if you guys have. Let me check. Nobody pinged in the chat, please. If you have any questions, please ping in the chat. And if you can't ping in the chat, yeah, Jairam, are you not able to send the chat message? I have messaged. Can you see if you can reply on that? Okay. I have allowed you to talk, Jairam. You can speak up.
Hello, sir.
Yes, Jairam.
Good evening, sir.
Yep, good evening.
So, how to write test cases and test scenarios? Sir? What is the difference between test cases and test scenarios?
So Jairam, I'll be covering all of that in detail. Okay, like what will be the requirement, from the requirement, how you're going to write the scenarios, test scenarios, and then how you're going to elaborate those test scenarios into the test cases. Okay, so all of that will be coming in upcoming videos, in upcoming live classes. So don't worry about that. Okay, so that's kind of the, I think 3-4 more classes. After that we'll come to that actual writing scenarios and the test cases. Okay.
Okay, sir. Thank you.
Yeah.
Thank you, sir.
All right. Naveen. Yes, Akansha, I've allowed you to talk as well.
Hello, sir.
Yes.
Good afternoon, sir.
Good
Sir,
afternoon.
I have a question.
Mm-hmm.
How entry and exit criteria relate with agile method?
Okay, so that's what I was telling in the just last couple of lines. So basically, entry at criteria you can correlate with the definition of ready. Okay, in agile, so Scrum has a definition of ready, and then exit criteria is definition of done. So when we say entry criteria, it's basically, say for example, you are going to an airport to catch the flight, right? What would be the entry criteria? The entry criteria basically, what are the prep activities or the things that you definitely need before you can go ahead and board the flight, right? You need to buy a ticket. You need to book a taxi in advance so that you can basically go ahead in time and reach on time, right? You need to carry your passport if you're traveling internationally. So all of these criteria, right? In general English, general normal travel, you need to, you basically prepare yourself, right? Before you can go ahead and board the flight or board the train. Now, similarly, in the software, when you're testing, when can we say, yes, testing can start? Build should be available, right? So developers should have actually finished coding. They should have finished the unit test. Okay, so these are some of the bullet points that need to be documented, and that's what entry criteria is. And entry criteria was the term used in the waterfall approach, but then in the agile, this same thing is being said as definition of ready, right? So when we say definition of ready, basically when can we say that this user story can be picked up by the team to start work? Okay, so that's what definition of ready is. So when the business analyst is writing or documenting the user story, have they documented everything? Have they captured all of the gaps, all the scenarios that need to be built, right? So all of those things, when all the bullet points or the tick marks are being met, then it can go to the next phase or the development phase. Similarly, from development, when can it go to testing phase, or when can we say definition of done, right? Which is exit criteria. So has developer done all the coding, unit testing? There are no issues. When can we say testing is done? Testing is done when all the functional scenarios, all the test cases have been executed, no severity 1 and 2 defects remaining. So these are some of the things that go into definition of ready and done. Okay, and you can correlate entry and exit criteria with definition of ready and definition of done. And this is the team. So basically team discusses, and these criteria are being discussed and can be changed during the project by the team. Okay, there were a couple of more hands raised. Who has raised the
Thank you, sir.
hands? No worries. Who else? Okay, I will. So I'm not sure what the name is, but yes, I'm allowing you to talk, please. Yes, please go ahead.
Hello, sir.
Yes.
Yes, sir. So actually, can you explain me about that environment, test environment? I'm not clear about that.
Okay, sure. So see, test environment is Now, if you have to, like, if you're aware of any of the e-commerce website, whatever e-commerce website you go to for shopping, right? Now, on your phone, on your laptop, you can basically go ahead and access the website. All right. But then there is continuous development that happens, right? So if you are, if you say Amazon.com, everyone would be aware of. So Amazon, we go ahead and do shopping. Now, every day there is new feature that is being rolled out in Amazon.com. So there would be defects that they use to address. Now, when the development happens and the new feature is being rolled out, so it's not directly deployed to the production that you can directly access, right? It is basically first tested internally within the development team. So when it is tested, there is a server, you can say test environment is another replica of the production, basically not exactly production, but then a server that only testing team and development team has access to, wherein any new feature that they build, they deploy, testing team tests it, and when they find that yes, everything is fine in that particular feature, then they roll it out to the production. Okay, so then that particular feature moves to the production. So say for example, $1 billion sale, right? Or big billion sale, whatever, like any sale. So these sale or features that are being launched in different festivals, so these are first tested internally that yes, proper discount is being applied when person buys the products of this amount, they get this percentage. When they buy this amount, they get this percentage. So all of this is tested first in the test environment, right? And then this is being rolled out to the production, wherein end user, so for example, we are buying something in our festival, then we'll be able to go ahead and buy it, right? So feature is first tested in test environment, which is nothing but a server wherein the features that are being developed, they will be deployed, tested, and then when everything is good, they are then moved to the production. So test environment is a test server that only testing team and development team or software development team has access to, not the public. Okay.
Okay, sir. Yes, thank you, sir.
No worries. Okay, so let's move on, and at last I'll take some more questions. Okay.
Okay, sir.
Okay. Now, what are the objectives, right? So objectives: evaluating work products, preventing defects, right? So when we say evaluating work products, same thing, right? Static testing, going through requirement document, design document, user stories, etc., and verifying that everything is good, there are no gaps, requirements are clear. It's not like you are going to build an email application, but then email functionality itself is not being defined and those features are not being yet documented yet in the requirement, right? So those sort of things need to be found out by the testers. Now, second thing is avoiding preventing mistakes throughout the SDLC. So it's not just one phase that you as a tester are involved, it's throughout the software development lifecycle, avoiding any mistakes or providing your input and feedback to the team. And defects, identifying defects, because early defect identification will save a lot of money for the organization. And we'll see with this, with the calculation, how much a defect can cost if it is found in production, right? It's massive amount of money that goes in fixing any of the issue that is found in production. So determine that the software meets product requirement and customer needs. So requirement that have been articulated in the requirement document, first thing, and then whether it fulfills the customer need. That's the another thing. That is the another objective of testing. Now, determining that the software is fit for use. Yes, it's not just that the customer that the software meets the requirement, but then if it is not fit for use, I want to send email, but I'm not able to send email. What is the purpose of that Gmail or that email application wherein I can format email in so many different formats, right? It's of no use. It's kind of just a document for me. So that's sort of a fit for use. Is safe another thing? So for example, in the medical industry, in airline industry, there is a lot of software, right? So in airplanes, there is a lot of software. So those sort of software and application that go in an airplane, are they safe, right? Or are those software safe, fail safe? All of that is very much required and needs to be tested. Now, finding failure, defects, bugs, absolutely. This we have seen that this is kind of a across the life cycle, you will be finding failures, defects, that if you are testing something and you expect that when you place the order should go through and the order should be available in the backend system so that somebody can see what order has been placed and then they can fetch those items and dispatch it, right? But if the order has been placed and the message customer has got order placed successfully, but then that order didn't flow to the backend team of Flipkart or Amazon, how would they know that you have placed this order, right? So if there is anything which wherein discrepancy, order customer is getting order placed successfully, but then order doesn't flow to the backend team so that they can fulfill the order. So if there are any cases like that, that means basically it's a defect, discrepancy. So finding these sort of issues. So this is just one sort of example, but then there'll be hundreds and hundreds of defects that you usually find during the whole life cycle. And then reducing risk. How does risk reduces with the quality? Basically, when you do static testing, any gaps that are identified are being addressed upfront, which then lead to better code being developed based on the requirement and the acceptance criteria that is being defined in the requirement. So eventually, this whole activity will reduce the risk of issues or defects being passed on to the production phase, wherein if the software fails in production, it's kind of a reputation loss, lot of loss of business. So imagine Amazon.com doesn't work for a day, okay, or it's down for a day. Can you imagine how much loss? I mean, it could be, it will be millions and millions of dollars in loss of business, right? So when they test something, that will eventually ensure that whatever they have built is actually working fine, and eventually it will reduce the risk, right? And then building confidence. So basically, when I test something, I see the expected result that I want to see, and that is defined by the in the requirement, and that is what customer is looking for. Obviously, the confidence in the product will be high, right? So when you test and you see things happening the way end user wants, the way requirement have defined it, it obviously is going to build the confidence. So testing builds confidence, right? And it focuses on a defect prevention process, which then allows less errors to flow, right? So when you go ahead, analyze requirement, then find the gaps, then eventually if those gaps are addressed in the requirement phase itself, so you are stopping the defects flowing from the requirement phase to the further phases. If you as a tester are not getting involved in the requirement phase and you are not able to identify those gaps then and there, obviously that gap is going to be addressed. I mean, it's not going to be addressed, right? So developer will just fall back to whatever requirement is there. They'll build according to that. When you are going to test it, then you will find, yeah, there was a gap, and where this gap was, it could have been addressed in the requirement phase itself. Now you can imagine how much rework will happen. So now the rework is that you will raise this defect in the testing phase if you are following that phased approach, and then this defect needs to be addressed in the requirement, then the design, then development, right? So you can see how much rework it will involve if the defect is found in the later phases. Okay, so that's where defect prevention is very much another sort of focus of the software testing. Now, what are some of the types of software that you could be testing? All right, so what are some of the types? So on a high level, there will be many types, right? But on a high level, if we try to categorize, so system software, like Windows, Linux, Mac OS, any of the computers that you use, right? Or mobile phone, iOS, Android. Okay, Nokia has their own OS, the mobile OS. So any of these operating system are the system software. Okay, or it could be other system software in this list, but these are sort of a popular software that you could be going ahead and testing. Application software is the software, the application that is installed on your machine. For example, MS Office, Google Sheets, or any of the application, whether you access over the cloud, over the browser, or it's installed on your machine. These are the application software, and mostly like 70-80% of you will be kind of working in the application software. Now, programming software are the software, for example, to write the code. So if you're working in the automation, writing test automation code, then you'll be using Eclipse, Visual Studio Code, PyCharm, etc. So these are programming software. So basically kind of three broader categories that I thought will be helpful for you guys to understand the types of software. So system software is the must, where you can basically then install application software or test the application software, and programming software are used to program any of these, right? Programming software are the interface that allow you to basically program your application software or system software. Okay. Now, another important concept to understand is SaaS, PaaS, and IaaS. Okay. So software as a service. Now this is very sort of, it's not a new term. It has been there, but then as a tester, we need to be aware of software as a service, platform as a service, and infrastructure as a service, and also understand the differences. Now, if we talk about software as a service, so software as a service, if you would have used Jira or Access Jira, or you used Confluence, Google Sheets, right, WebEx, any sort of meeting tools. So anything that you are accessing and you are not worried about anything else in terms of installation, in terms of basically which server it runs on, data and everything, that's all managed for you. You are just accessing that software, using it, that's it. Okay, that's a software as a service. And there is a fine line. Basically, there is basically, if you'll see this particular diagram, so everything, infrastructure, the memory, server, operating system, certificates, everything is being managed by the vendor who provides that software as a service, right? So Microsoft Office 365, right? I can just open the browser and I can sign up, pay the sign up fee, and I can start using Microsoft Office online. Did I had to go ahead and install something on my machine? No, right? So it's a software as a service. Am I bothered about the space? So I bought, 1 terabyte of space. As far as that space is available, I can use it, right? So any type of software wherein you don't have to manage anything at all, you just sign up and start using. Netflix is a software as a service, right? So any of these streaming services are software as a service. When we say platform as a service, like it's anything like OpenShift, Google App Engine, AWS, Elastic, Beanstalk, so Salesforce.com, right? So Salesforce is not only a software, but then you can also, it also provides the platform to build and customize the application, right? So that's what the platform as a service is. So along with the, if you see this PaaS line here, so this is the infrastructure, right? So along with the storage, certificate, server, everything, they also provide other functionalities, libraries, etc., middleware, wherein developers can go ahead and start using or customizing the application as per the needs of the customer. So that's the platform as a service. And infrastructure as a service, like Microsoft Azure, Google GCE, Google Compute Engine, Amazon Web Services, everyone would have heard of. So that's the infrastructure as a service. When we say infrastructure as a service, it's basically just the infrastructure, server, okay, certificates, and the storage. All right. Now there is a website. Let me stop sharing. I'll show you that. So So here you can see, this is the bmc.com blog, and here you can see that why people have moved to, or why organizations have moved to software as a service, platform as a service, infrastructure as a service, based on the need. So previously, like when I started my career, there was no concept of software as a service. It was kind of picking up. It started during that time, like 15 years ago, sort of 16 years ago. So everything was on premise. So when we say on premise, you will see that server, storage, networking, when we say server, Linux, Windows, OS, all of these machines were in the company, right? So there were data center, the servers were there, the storage were there. So basically any of the hard drive, everything was there. If we need to virtualize the server, virtualization was managed by the company. Networking was also done by the company. So all of that, if managed by the company, that's the on-premise. Okay, it's on-premise for the organizations. Now, if I have to, if I'm a organization that I don't want to manage any of this, okay, so I can go ahead and say I will take software as a service. So if I want to install Jira on premise, I have to manage everything, right? I have to manage the server. I have to get server first, then I have to get storage, then I have to virtualize if I have to use multiple instances, for example. So networking, so that the whole organization can access that Jira instance that is installed, the data runtime, everything I have to manage. But then if I don't want to do it, then I can simply go ahead to Atlassian.com and sign up for the Jira. Okay, so Atlassian is going to manage everything in Jira that is being needed. I just have to pay them monthly fee per user, depending on the number of users that I'm going to use, and then go ahead and use. So this is software as a service, when everything is being managed by the company who is providing that service. Platform as a service is basically all of the virtualization, server, storage, everything, along with the runtime, middleware, operating system, for example, salesforce.com. So you can also customize the flow, you can do some development. Apart from application and data, everything else is being provided by the platform as a service. With infrastructure as a service, we are just buying or signing up for the server, storage, networking, right? So for example, I can go to Amazon Web Service and I can spin a server. When I say spin a server, I can basically just launch a Windows server, and then I can SSH to that server. Basically, if it is I want to SSH a Linux server, or I can access the interface from my home computer, right? So this is Windows 10. I want a Linux server. So ideally, 15 years ago, I would have got another box, another machine in my home, and I would have installed a Linux on it, or I would have virtualized the same machine or made it dual boot and installed the operating system Linux. So that's how it was. But now with infrastructure as a service, I could go to Amazon Web Service and I can pay them some fee, monthly fee, and I can spin whatever operating system, whatever storage I want, and start using it directly. So that's what infrastructure as a service is. So this is very nice presentation basically. So you go ahead and it will clarify any of these doubts around IaaS, PaaS, and SaaS. Okay, let me share again. So next thing is product based versus project based. Okay, so now software testing you would be doing either product based or project based, right? So many of you might be working product based or project based. So for example, what is the difference between product based? So product based companies are the companies that develop the product for a specific purpose and then market it. For example, Atlassian develops, they have developed Jira and Confluence, right? So Jira and Confluence are the product, and then they sell these products to different companies. These Jira and Confluence are agile project management tool and collaboration tool that software development teams use during their software development lifecycle, right? So they have specifically built these products and then they're selling it. So any product-based company will develop the product and then they sell it. Okay. Then project-based companies are the service companies like Infosys, Capgemini, IBM Global Services, Accenture, etc. They provide services on different consulting, products, technology, all of that. So project-based companies are the companies which provide consulting services to other businesses, banks, utilities, education, government, etc. Okay, so that's the core difference between product-based and project-based. And similarly here, I explained this because you might be working in any setting. You might be working in a company which provides software as a service, right? So if you go to the interview tomorrow and they say we are a SaaS business, so you understand, yes, what exactly SaaS means. And that will give you an edge over other candidates who don't know what SaaS is, right? Or we are a PaaS service, or we are, you might be working in Google App Engine, say, for example, right? Or you might be working Salesforce.com. So they are platform as a service. Okay. Then infrastructure as a service, right? So Amazon Web Services. Okay. So that's where understanding these terms as a fresher is key as well. Okay, now let's quickly do this slide and then we'll connect again, right? So why, now we have understood a lot about testing, then why is testing necessary? So some of the examples here. So Nissan, a car manufacturer, right? So they have to recall 1 million cars due to defect in software, okay, in airbag sensor detectors. So now you can imagine that 1 million, recalling 1 million car because of this software defect, how much extra money Nissan would have paid in order to get all that rectified in 1 million car, right? So this is kind of the massive money impact, the budget impact that happens in case of the defect. And that is why testing becomes really, really necessary, so that we have minimal such incidences wherein companies have to have these kind of issues, right? Otherwise they'll go bankrupt, right? Fixing all of those defects. Now software bug, the next example, software bug caused a failure of $1.2 billion military satellite launch, right? So in satellite, if anything goes wrong, all of your money is gone, right? So that happened so many times. That happens so many times. There is not just one example. There are so many examples wherein billions and billions of dollars have been lost because of any of these defect failures, software bug failures. Software failures usually cost the US economy how much? US $1.1 trillion in assets in 2016. That's the calculation. That's the impact overall that happens if the defects are serious and cause so much damage. Okay, so this is basically, these are some of the examples why it is necessary in terms of money impact. The second thing is, it doesn't look good for a reputation of the company. It's a bad reputation if you are delivering product, or if you are launching a product in market which is absolute bad quality, you are actually compromising with the quality of your first thing, you are compromising with your brand name, right? So no good brand wants to take that risk. So money loss is first thing, then reputation loss, people will start leaving you and eventually you will be out of the business, right? So money loss, reputation damage, testing becomes necessary in order to ensure that any of these impacts that impact the company reputation because of the defect, the impact of the funds, or basically the loss because of these defects, that all gets reduced when we have the testing in place, and testers basically go ahead and test the overall product. Okay, so these are some of the key points. So basically, it will reduce the risk of the software failure. It will testing accelerate software development, and is also required as part of the contractual agreement. That's another thing. For example, if you are testing any application which is from the for the hospitals, right? So it needs to meet the contractual agreement, the legal requirement for the appliances that are used in the in the hospitals, right? In the airplane, because there is a life risk as well. So their testing becomes important as well, that the contractual agreement and legal agreements are being met. That is also being verified when we do the software testing, right? So these are some of the key points wherein testing becomes really necessary. Okay, so let's stop here and then we'll start from the next slide in the next session. Okay, and you all will get an email whenever we are going to conduct the next session, so you guys are aware of. Okay, have a great day ahead. Thank you.